Hello and welcome. I'm Adam, the Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. This is part 4 and the final part of our Predicting the Stock Market with Machine Learning series. In the last video, we put together our data set to get ready to feed into a logistic regression function. For those of you who missed that, I'll link to it now. We also have 2 parts before that where we were exploring how to use linear regression to predict a single stock. So if you didn't check those out, definitely go ahead. But for now, we'll jump over to the Jupyter Notebook and start putting our model into action. Okay, as you can see, I'm over in the notebook right where we left off in the last video. For those of you joining new and you don't want to go ahead and put that data set together, that's all right. I have the link right here. You can go ahead and just download it from that GitHub page. But without further ado, let's go ahead and get started. First thing we need to do, as always, import some libraries. So we are going to be importing pandas. So go ahead and import that. Pandas is PD. And we'll go ahead and import NumPy as well. I'm not sure where we use it, but go ahead and do that one. And last one, we'll do matplotlib. .pyplot as plt. Once you get those in, we can go ahead and start. Like I said, download that data set or just know wherever you downloaded it. And I'm just going to read mine in. So mine is actually saved as S&P 500 data. So we're going to use pandas to read that in. We do a read CSV SP500 underscore data.csv. And I will just display our data. Okay, so we have a whole bunch of data here. Now we have some missing values we need to take care of, and we have some preprocessing that we need to do before we can feed this into the model. So let's go ahead and take care of all of that. I'm just going to drop down to the next one. And actually, I'll go back up here. I don't want to really waste that much space. So let's say first thing we need to do is we need to convert the sector into a number value, because right now it's a string and machine learning does not like strings. So let's go ahead and just quickly put some codes. So Pandas actually has a function built in that allows us to convert strings to their code equivalent. So let's go ahead and do a data at sector is going to be equal to the data at sector dot as type category. So what this is doing is it's converting from a string type to a category type. There's a built-in type that is category, and you can see what we're about to do with that right now. So data at sector is going to be equal to the data at sector. Now, since it's already in category type, we can say .cat for the categories, and then we can do .codes, and this automatically puts an integer value to each one of those different categories. If I display, you can see our sectors are now numbers based on whatever sector they were in. I think there may be 7 of them, but I'm not positive. Doesn't really matter. I just converted them to a string. So perfect. Now there are a couple, at least one anyways, not a numbers in the results. So actually if I go down here to my display function and I do a .isNA, and then I do it followed by a .sum, this is going to tell me each one of my categories where am I missing some numbers. So you can see I'm missing some numbers in the middle, but actually right here. So results equals 11. If I don't know the results, there's no way for me to do any sort of interpolation or any sort of filling in those missing values for the results. So we're just going to go ahead. If there is no result, then we're going to drop that. To do that, we can say data.dropNA. You have to make sure to do a subset, or else we're going to drop every single row in here. And the subset is going to be equal to the result column. And I want to say in place equals true because I did not reassign it at the beginning. So now if I go ahead and do that, you can see our results have 0 missing values. Okay, now we do need to address the other ones, but one other thing that we need to do is we need to, I I go ahead and display the data again, I'll show you. Let me just show you data at result. Okay, so data result, if you remember when we built this data set, is the percent change over the year. So it's a good value, but what we really want to be predicting is we want to try to predict maybe tiers of uh, percent change, right? So maybe the first tier will be any negative number, and then the one after that would be from a 0 to a 25% return, and then from a 25 to 50, and then 50 on, or something like that, to just give to just kind of bin these classes a little bit. So pandas lets us bin those fairly easily. Go ahead and define this as bins. So let's actually look at their distribution first. So plt.hist, this is just going to do a simple histogram. So I'm going to pass in data at result. Okay, here's a histogram of all the results. So you can see a lot between -1 and 1. And then we do have some outliers way out here with like a 7. So I think those bins that I laid out. So anything below 0 will be the first bin. Anything 0 to 25%, and then 25 to 50, and then 50% on will just take care of all the other outliers. So let's go ahead and do that. Getting rid of this PLT, I'm going to say bins is equal to. Now I want to catch outliers. Like right now, my lowest value isn't below -1, but maybe in the future it would be. So I'm just going to do a catch all, just super low, -10. And then we will say -10 up to 0, because that covers all the negative numbers. Now I want to go 0 to 25% return, 25% to a 50% return, and then a 50% on. So I'm just going to do another 10 just to capture all of those. Now I can say data at result underscore bin. That is going to be equal to pd.cut. This cut function is automatically going to bin those for us. So we're going to cut the result, and we're going to cut them into our bins. So pass in bins. Okay, so that is going to put them into intervals, and it's going to say, the interval of 0 to 0.25. But what we, again, like we did up top, we want to make those categories. We want to only have to output 1, 2, 3, or 4, depending on whatever the category is. So I'm going to copy a lot of what I did up here. So I'm going to copy this as type to category, followed by that .cat.codes. And that is going to convert these into our nice bins for us. So instead of printing result, let me go ahead and print result bin. And you can see now these are binning based on how much of the return there was. Okay. So that is what we're going to use to predict, so we can actually just drop the result column. But I do want to keep that around just so I can use it for testing and reference back to that when I go to make the actual results. So I'm going to just copy that into a temporary variable called %change. And now I am going to drop the column. So data equals data.drop. We are going to drop the result. And then it's going to ask us for whatever axis we want. So axis 1 is the column. Okay, so this will drop that column for us. Now we can start to split out the data. Now the reason we're going to split out the data before taking care of the missing values, remember we had a whole bunch of not numbers and we need to fill those in. So we'll probably fill those in with like median or something easy. If you want to get a little more advanced with that, there's other ways of filling those in, smarter ways, but just for learning's sake, we'll just fill those in with medium. But the reason we want to fill them in first is because we don't want to carry over any biases from the testing data to the training data. So we want to make sure all of our processing steps are done using things we learned from the training data and then applied to the testing data. So first thing, we need to define our X and Y. And X is going to be equal to the data, where the data dot columns. Okay, so the first two columns we are going to remove because it's the year on the ticker. It doesn't really need those. So we're going to start from 2. And we're going to go up until -1 because that is our results bin. So we don't want to include that. I can just do a quick display data. You can see. So we don't want to carry in the ticker. We don't want to carry in the year. And then at the very end was our results bin. So that's going to be our X data. Now for Y is going to be equal to the data at that result bin. And so now we have our X and Y ready to go. I'm going to delete this display. Okay, so now we need to split our data into training and test sets. So what I'm going to do is I'm going to take the most recent year, which happens to be 2020 for this data set, I believe. And so 2020 refers to the report was released in 2020, but it is we're going to be projecting out for the year 2021. So let's go ahead and say train index is going to be equal to the data where the data at year. So I want to figure out where the year is less than 2020, and I want to take all that data. And that is, we're going to take the dot index dot values. So it's just going to pass me all of the index values associated with any point that was before 2020. The index values are this leftmost column. Okay, so that is the train index. And then I'm going to copy that because we're just going to modify this slightly. It's going to be the test index is going to be equal to whenever the year is equal to 2020. Now you can't do greater than or equal to because there are values associated with 2021, but we do not know the final values for those because we're currently 3 months into 2022. So don't accidentally include 2021 data, 2022 data, because we don't have the results for those to do the training. Okay, so now we have our X and Y data. We have our training and testing indices. Now we can split our training and test data out. So I'm going to define xtrain. It's going to be x.locate, and we're just going to locate those indices. So train idx. And that will take care of all of the xtrain data. Let's go same thing for test. So pass in the test indice this time. And if you copy both of those and bring those down, we can do the same thing for y. Just replace all these x's with y's. Okay, so we have our training and test sets. Now, one way to take care of outliers, that's the first thing we need to do. So outliers are any number that's way larger or smaller than the rest of the distribution. One way to take care of that is to look at the interquartile range. And we can define some gates to figure out if any point is greater than this or lower than this, we should correct those. So we can define the interquartile range. So IQR is going to be equal to X train. Now remember, this is very important. Make sure you're using the X training data and not including the test data to do this. So we're going to do a dot quantile. We're going to take the third quantile, so 0.75, so 75% of the data, minus, if you go ahead and copy this first part, we're going to be subtracting the first quantile, so that's going to be 0.25, so 25% of the data. So this is the range between the bottom 25% and the top 25%. And so we're going to define lower, which is going to be equal to xtrain.quantile. So lower is going to be anything lower than the first quantile, so 25% of the data, minus 1.5. 1.5 is just a typical number you use here. You don't have to use 1.5, you can use 1, you can use 2, but generally 1.5 is what you want to use. But 1.5 times the interquartile range. So anything below that we need to address. And then if you copy this, we are actually going to do the same exact thing for the upper. So the upper is going to be equal to the third quantile, so 0.75, and we're going to be adding 1.5 times the interquartile range, and that's going to give us where our upper limit is. So anything past that, we need to address and bring back. Okay. So now what we're going to do is we're going to iterate over the data frame. We're going to find all the values that are lower than the lower limit or greater than the upper limit, and we're going to just assign those to the lower or the upper limits. So for I in xtrain.column, so we're going to iterate through each of the columns. We are going to say xtrain.locate. So we're going to locate xtrain at I. So wherever the current column we're on, we're going to pass that in and say wherever that current column is less than the lower at whatever column we're trying to address. And then we want to reference whatever that column is, so pass in I as well. And we're going to say that is equal to the lower at I. So again, this locate is saying wherever the current column that we're on, wherever that is lower than the lowest, we're going to take that column and we're going to set it equal to the lower limit. Okay, that addresses all of the lowers. You can copy that because we're going to do the same thing for the upper. We're going to look for wherever it is greater than the upper. And we're going to say that is going to be equal to the upper limit. So just pulling in all of those outliers. Now you can copy both of these. Now that we've done it for the training set, let's go ahead and do it for the test set. Okay, so it's going to be wherever the test is lower than the lower or the test is greater than the upper. And that should address all of our outliers. Next, what we need to do is we have all of those missing values. So we need to fill those in. And we're going to fill those in, like I said, using the median, just because it's quick and easy. And for the most part, it doesn't take into account all of those outliers that we just moved. So we're going to say, we had to start with the x test. So x test at I. So we're only filling in one column at a time. So the x test at whatever column we're on, dot fill in A. This is going to automatically fill in missing values. We want to fill that with x train. Again, very important to use train here to calculate the median because we don't want to leak information about the test set to the model. So x train at I, so at whatever column we're using, dot median. I'm just going to say in place equals true since I didn't assign it. Okay, so that fills the x test. Now that the x test is filled, we need to fill the train. The reason I started with the test is because I am calculating the median here. If I were to have started with the train, my median would be off when I went to calculate it for the test set. So I'm filling x train with the same thing. Okay. Last step we need to do is we need to normalize our data. So a lot of our data is, if you look down here, we got something 0.03 all the way up to 3.8. There could be more in there. So we just need to put everything between 0 and 1. So we're going to do that by, again, starting with the test set because we don't want to accidentally ruin our distribution when we do it. So we're going to say the test set at whatever column we're on is going to be equal to the test set, again, at whatever column, minus x train at whatever column, dot min. So we're taking the minimum of the training set, and we're going to divide it by x train dot max. So the maximum minus x train. This is x train at I. Make sure you put that in, or else you're going to have an entire list going in here. So x train, we're taking the max minus the min. So this is min max scaling, and that will put our numbers between 0 and 1. Copying that down, now that we've taken care of the test set, we can do the train and just go in here and change this back to train. And that will give us everything we need. Let's just make sure we have everything correct. So I'm just going to do a print xtrain.shape, xtest.shape, ytrain.shape, and ytest.shape, just to make sure everything looks correctly and we can see how much data we have. All right, so we have 1,267 points to train from, we have 18 features, and then we have 476 points to test from. So we are looking good. We can now import our model. So we are going to be using sklearn to import our model. So from sklearn linear model, we're going to be importing logistic regression. That's what model we're going to use. I do have a video on logistic regression, high level. If you're interested, definitely go check that out. Highly recommend it if you haven't used logistic regression before, or you're just not sure how it actually works. But anyways, let's go ahead and from sklearn, I realized I made a mistake up here. Make sure that says from. Okay, so from sklearn.metrics, we are going to be importing accuracy underscore score. And that should be good. Okay, go ahead, import those, get our model in there. And now that we have those in, we can make our model. So model is going to be equal to logistic regression. I'm just going to say max iterations is going to be 1,000. So it's going to have a maximum of 1,000 iterations to try to fit this. We're going to say model equals model.fit. We're going to pass it in the training data, so xtrain and ytrain. Next, we're going to make predictions. So it's going to be preds is equal to model.predict. Pass it in the testing data, only the xtest. And now what we can do is do a print accuracy score of preds and y test, and run that. Okay, so we have a fairly low score, but that doesn't really mean anything because we have so many and we're dealing with money here. What would really be helpful is to know how many times, really what we're trying to do is, as long as it predicts positive for us, that's a win. I don't care if it accidentally predicted it as a 3 instead of a 4. They're both making a lot of money. Now, if it was predicting a lot of negative values as positive, then we're going to start losing a lot of money. So we got to figure out a different sort of way to find out how we can do this accuracy score. So if you remember up at the top, I had that percent change, and that was storing all of the real percent change for each of these, and not the bins that we were trying to do. So we can say, first I would actually just want to see what the preds were and what the y tests were. So for x in range, length of preds. So for each of the predictions, I'm just going to do a print preds at x, and then yeah, I guess it doesn't. Yeah, y test at x. Let's just see how this looks. Okay, I do have an error. Oh, that's why. I'm gonna have to not do it this way. So I'm just going to print preds and then print y test. All right. So the reason that error came up is because when we split the data, I did it and I didn't reset the indices in the data frame, so there is no 0 indice anymore because it's actually in the test set. So I'm not gonna worry about that. I'm just going to print the results. All right. So I'm going to print the dot values for the y-test just so we can see all the numbers. All right, so in here you can see we got a distribution of all the different numbers. Now, if I say I want to predict the preds where the y-test is greater than 0, this should give me all of the positive numbers. Okay, so you can see there are some zeros in there. Now maybe if we keep going up, now greater than 1, we do still have some zeros in here. Greater than 2, yeah. So we are losing some money, but now it depends on how much money we're actually losing. So if I say print percent change, so percent change is all those associated with the y-test, they're all of the percent change numbers. So I'm going to say percent change at the test index. This will give us all of the test values for percent change. And I'm going to say dot mean. So this is on average how much was the return. If I just blindly invested into everything evenly, I would have gotten 33% return, which is a really good year for the stock or the S&P 500 that year. So you would have got a 33% return. So now, not only do I want to say, is my model better than, getting me more money than nothing? I want to actually beat if I just blindly invested into this. So I have to beat 33%. So if I say print percent change, and this time I'm going to say percent change at y test, where preds is greater than 0. And then I have to say dot index dot values dot mean. Okay, what is this doing? Let me explain this. All right, so I am taking the true y-test values for wherever the model is predicting greater than 0. So when the model predicts greater than 0, it thinks it's going to make money. It doesn't really matter how much money if it's just greater than 0. So it's taking any point the model thinks is going to make money, and it's returning the index back and then putting that into percent change. So we have all of the percent change where the model thought it was going to make money. Now we're going to take the mean over where it thought it was going to make money. And as you can see, we are about even. We actually lost a tad bit here, a couple 0.2%, I guess. So it wasn't perfect. Now, as we start increasing what classes we're trying to predict, so I'm going to say I want to know where it's greater than 1. So the model should be more confident now, and hopefully make us money. And actually, it didn't. So we're down 1%. And now, if I do 2, this is where the model should be most confident. This is all of the super large returns way at the very end. So hopefully this one will return us some, and it does. Okay, so now our model is giving us a 10% return because it's super confident that these ones way out here are going to go up, and they go up a lot. So this model ended up making more money than if we would have blindly invested, which is ultimately what we're trying to solve here. Now, you can definitely increase the fidelity of this model just by adding in more data. Even we're taking all the stuff we learned from the first 2 videos where we were creating a whole bunch of indicators on stock prices. You can add those into here. There's a whole bunch of other fundamental data that you can add in. You can we aren't training on that much data. We're only 4 years in the past. So you can go ahead and find websites and scrape websites for more data to collect on more years, and you should see this accuracy go up and up. But for now, just as a beginner model, this was worked fairly well, and it was pretty easy to put together. So I'm hoping you're able to take this and expand upon it into something that you may be able to actually use. I would not recommend using what we just did here to actually trade on the stock market. I never would recommend that. So definitely make sure you're confident in what your model is doing if you before you actually invest with it, right? There's things like paper money where you can trade stocks just for theoretical dollars, just to make sure that your model is consistently giving you results and it's not just a fluke. So definitely things to consider. But for now, I'm going to stop here. Thanks for joining me. Again, there's a lot of stuff you can do to improve upon this. So I hope you go ahead and take the time to increase the accuracy of this model. But I will see you in the next video, and thanks for joining.